Program or project evaluation and review technique. This is our lecture today. It is a statistical tool used in project management which designed to analyze and represent the tasks involved in completing a given project. PERT is a method of analyzing the task involved in completing a given project, especially the time needed to complete each task and to identify the minimum time needed to complete the total project. It incorporates uncertainty by making it possible to schedule a project while not knowing precisely the details of durations of all the activities. It is more of an event oriented technique rather than a start and completion oriented technique, and is used more in these projects where the time is the major factor rather than the cost, like software development. It is applied on a very large scale, one-time, complex, non-routine infrastructure, and on research and development projects. PERT offers a management tool which relies on arrow and nodes, diagram of activities and events. I'll be explaining everything one by one afterwards. PERT and CPM are complementary tools because CPM employs one-time estimation and one cost estimation for each activity. PERT may utilize 3 times estimate: optimistic, expected duration, and pessimistic duration, and no cost for each activity. Although these are distinct differences, the term PERT is applied increasingly to all critical path schedules. So let's start with it. As I said, that PERT stands for Program or Project Evaluation and Review Technique. This technology dates back to 50s when it was invented by US Navy and its consultants Booz Allen and Hamilton. It was developed primarily to simplify the planning and schedule of large and complex projects. It was developed for the US Navy and particularly for Navy's Polaris nuclear submarine project. So what it does, it presents in the form of a network chart. Network chart is something like this. We will be looking into it further. PERT is less commonly used than their relatively more commonly seen siblings, the critical path method, or CPM as it is called. The critical path method or CPM uses activities on nodes. These are the nodes, and these activities are connected by lines. Whereas the PERT flips it over and it shows activities on connecting lines like this. This is A activity and this is B, and then the nodes show the branching structure of the network chart. So that means that activities are connected through these nodes. The second difference is between the two techniques is of more substance. So as we will be focusing more over PERT than CPM, critical path method, but critical path would be the part of our deal here in this video as well. So let's get indulged into more specific and detail-oriented explanation. The second difference between the two techniques is of more substance. The CPM is much more simpler single point estimation for the duration of an activity. Duration the activity will take will go in the model this way, means it would only be written that the duration of a particular activity is 5 days. Whereas in PERT, we use 3-point estimation for every duration. First, like critical path method, it is called most likely, that is equal to 5 days as we have denoted over here. And then we have longest we think it will take to complete that activity, that is 9 days, and we call it pessimistic. And thirdly, how fast we think it may take to complete the project, and that is goes by the name optimistic, and that is 3 days. So instead of having just 1 point duration, we have 3 points estimated durations. Uh, Typically, these estimates are not symmetrical, as optimistic is not at the same distance from the most likely as the pessimistic. So the difference between optimistic and most likely is 2 days, and whereas from most likely to pessimistic it is 4 days. So for that we have to find an average or something. Let's see how. Now, most likely is 5 days, pessimistic is 9 days, optimistic is 3 days. We go by these variable, M for most likely, P for pessimistic, and O for optimistic. So their differences give us a triangular distribution. So something like this. This is optimistic, this is most likely, and this is pessimistic. So how to deal about it? As a result of simple mathematics, we can therefore estimate the average duration of the task based on these 3 estimates. But we don't give equal weightages to all these 3, because there is a reason we have the most likely, because we think that most likely is more credible than any other. So we give it a higher rating. So let's say 1 to 4. So we multiply most likely by 4, optimistic by 1, and optimistic by 1 and pessimistic by 1, and we divide all by 6 to get a proper average for the duration of the task. We can give more weightages to optimistic and pessimistics than most likely, and that can be the case. It will be given in the exam question if it is that case. Otherwise, it is always that optimistic is given 1 weightage, pessimistic is given 1, whereas most likely is always given 4. We can change this approach by finding a mean by giving pessimistic a weightage of 2 and dividing by 7. That can also be done. We can also calculate the standard deviation to get some idea of likelihoods around our averages, or average, sorry. And the way we calculate, that is, we subtract the optimistic estimate from the pessimistic estimate and divide by 6. That would be the standard deviation thing. So basically, PERT is a method for estimating the duration of project, firstly by building a network where the convention is that we use the arrows to define the tasks, and then the nodes show the arrows relate to one another. Secondly, the length of these arrows, the divisions basically, the duration recorded on those arrows are based on the on 3 points estimates, from which we could calculate average duration and standard deviation. With today's modern softwares, where PERT techniques are available through software, it is very straightforward to put in all of the estimates for all the tasks, and I mean by putting in, I mean that input, and for the software to calculate not only the average duration for the whole project, but composite of all standard deviations up, and figure out the likely spread of the most optimistic, the most pessimistic estimate for the whole project. Let us start with the example chart and problem for the PERT. Consider the following table summarizing the details of the project. We have got activity, predecessors, durations, which include optimistic, most likely, and pessimistic. So let's talk about the terminologies first. So there is a terminology we might be using, that is event. Event is a point that marks the start or the completion of one or more activities. It consumes no time and uses no resources. And then we have this activity, the actual performance of a task which consumes time and requires resources such as labor, materials, space, machinery. It can be understood as representing the time, effort, and resources required to move from one event to another event. A PERT activity cannot be performed until the predecessor event has occurred. So now, what is a predecessor? Predecessor event, an event that immediately precedes some other events without any other event intervening. An event can have multiple predecessors events and can be the predecessor of multiple events. So let's see, for activity A, B, and C here, there is no predecessor. But to start activity D, we have to have activity A completed. So A is a predecessor of activity D. Similarly, to start E, we have to have this B completed first, and for F, we have to have C completed. So once the C is completed, then F starts. Similarly, after the completion of C, G also starts. So F and G will simultaneously be starting from C. So C is the predecessor for both F and G. Whereas for H, it has to be E and F completed first. So H activity cannot be started until the events of E and F activities are completed. Similarly, for I, we have to complete D first, and then for J, we have to have H and G events. For these activities, G and H should be completed. That is how the predecessors and activities work. Let's start with the durations. Durations might be in hours, in minutes, in days, in weeks, in months, in years, whatever that would be, whatever the unit that we have will be given in the question. So PERT has defined um, different types of time required to accomplish an activity. So first we have optimistic time or optimistic duration, the minimum possible time required to accomplish an activity or a path, assuming everything proceeds better than is normally expected. That is optimistic estimate. So we have most likely 6 weeks estimate for A, but if everything goes well, nothing comes in between, then A will be completed in 5 weeks. Whereas we have pessimistic time, uh, the maximum possible time required to accomplish an activity, assuming everything goes wrong, like in here, we assume that everything goes well, uh, everything goes wrong, but excluding major catastrophes. So this is the most pessimistic time. And then we have most likely time, the best estimation for the time required to accomplish an activity, assuming everything proceeds as normal. So using all these three, we have then expected time that we will be shortly calculating. The best estimate for the time required to accomplish an activity, that is TE, uh, that is how we calculate the most estimated time from all these three values. Now, for the same chart that we have just seen for the activities and their predecessors and then durations in optimistic, most likely, and pessimistic ways. This data will be given in the question. By having this data given, we might be asked several questions. So for the problem that I have presented, we have these 4 questions. Construct the project network. Number 2, find the expected duration and variance of each activity. As I told you that we have got optimistic, most likely, and pessimistic durations. We will be calculating expected durations and the variance of each activity. Third question is find the critical path and expected project completion time. So we will be, once we have this project network done, the project diagram, the network diagram, we will be able to find the critical path. This is as it would be with CPM critical path method, and expected project completion time. And then we will have to find the probability in question number 4 of completing the project on or before 22 weeks. So to answer this question, construct the project network, I have borrowed these 2 columns from the original problem. So in order to construct the project, all we need is just activity and their predecessors. So we can see that activity A and B and C does not have any predecessor. So let's start making it. So for every activity we need 2 nodes. The first node where the event is starting for completion the activity A, and then another node that shows the completion of activity A event. So this is first node that is showing the start of activity A, and this is another node which is showing the end of activity A, and over this arrow we will put the name of the activity. Since A, B and C all are starting together and they don't have any predecessor, so for B we will be doing this way. This would be the node number 3 and also starting from node 1, and then we have activity C, which is also starting from node 1 and ending in node 4. So every time you create a new node, you will be giving it a subsequent number. So for every activity there should be a starting node and there is one ending node. So for these 3 activities A, B and C, there is no starting node, so they all will be started from the first node. So this is a starting node, this is ending node. So we have, this is starting node for activity A, ending node for activity A, starting node for activity B, ending node for activity B, starting node for activity C, and ending node for activity C. Every new node will be numbered, as I said, subsequently in a series. Now for the next activity, that is D. D starts when activity A ends. So activity A ends here, so from here D will start. So this new node will be marked 5. Afterwards activity E. Activity E starts when the B ends. So B ends here. So afterwards E will start. Now for activity F. Activity F ends, starts when the activity C ends, but over here in the column of predecessors we can see that activity F ends along activity E. So that means that E and F will be ended at the same node. So you need to understand that you would have to observe this predecessor table, where if you see 2 activities are the predecessor for one of the activity, then you would have to make sure that these 2 end together at the same node. Afterwards we have G. G starts when the activity C ends, so it will be starting from the C and will be ending at node 7. So now we have got 7 nodes and we have finished until G. Now H starts when both E and F are finished. So we can see that E and F are finished at node 6. So from this node 6 we will have our H started. Now we can see that why we have ended this H at 7, because if you see in predecessor H ends along G, so G already ended at 7, so we have to make this H goes to 7th node as well. So let me tell you once again, if there is an activity which is ending along another activity in the predecessor table, then you would have to make it finish or end with the same node where the other activity ended, because they both are the predecessor for J. Now next, so H is finished. Now we have got I starts when the D finishes. So D finishes at node 5, so we will start I, and I will be ended at 8, and then we have got J. So J starts when both H and G are completed. So our J is the last activity on the table and for the chart, network chart, so it will end at the last node, which is 8. So as the first 3 nodes started without any predecessor, they all started from node 1. Similarly, the last activity will be ended at the last node, which is 8. So as we were already numbering, we would have a fair idea that which node is the last one. So this J will start when both H and G are ended. So J will go from node number 7, that is the start of J activity, and ending node would be 8. Now that is how we construct the project network. So let me revise it fast. So for constructing the project network diagram or PERT diagram, we have to have 2 columns, activity and the predecessors. These activities are the activities on the project. Over here we have taken it as ABC. For a particular problem or project, these activities would have their own names. Over here we can see that all 3 activities A, B and C are starting without any predecessor. It means they all are starting together, so they will be starting from the node 1. So A starts, and when A ends, it should end at another node, and that would be the second node. We will make it 2, and we will put these arrows show the activity. Then we would have another node 3. Activity B will start from node 1, go to 3, and then we would have another node there, activity C start. They all 3 start from the first node because they don't have any predecessor, so they all will be starting together. D starts when A ends. So A ends at this node, so we would have another node here. As we had already 1, 2 and 3 node, this would be the 5th node. E starts after B ends, and then we can see that E ends along F. So when we would have F, which starts when the C ends, ended at the same location, because they both will be the start of another activity H here. Then we have activity E that starts when activity B ends at the 6th node, and then we have activity F that starts when the activity C ends here, and then we have activity H that starts when E and F both finishes at node number 6. But we would have to have this idea that this H also ends along G, so we would have to make this G when E and F finishes to the node where G already finished, so G already finished here, so we will make this activity start from node 6 and add and end at node 7. Afterwards we have activity I, which starts after activity D here at node 5. Then this would be the last node, which is 8, and then since J is the last activity, it will be ended at the last node and will start once where the H and G both are finished. So that is how we create the project network diagram. Alright, with question 2, which is that find the expected duration and variance of each activity. For this particular question, we have to have the durations which were given in the question, and we have got three durations: optimistic, most likely, and pessimistic, where we denote optimistic with O, most likely with M, and pessimistic with P. So we have got these three durations for every activity. Remember, these durations are in weeks. Using these values, we will be calculating expected duration. Expected duration means mean duration, TE. So the formula for finding the expected duration, as we have already discussed, that we give weightage to most likely more than the optimistic and pessimistic. So we will take that. So this is optimistic in 1 week, pessimistic in 1 week, whereas most likely in sorry, not weeks, but the weightages. Optimistic has 1, pessimistic has 1, and most likely has 4. So altogether they are 6. So this will be divided by 6. So for every given duration, we will have to, for activity, like for activity A, we will have to multiply this optimistic by 1, this most likely by 4, and this pessimistic by 1, and their total will be divided by 6. So for activity A, 5 into 1 5, 6 into 4 24, 7 into 1 7, all added divided by 6 will become 6. For activity B, 1 into 1 3 into 4 12, plus 5 into 1 divided by 6 will be 3. For activity C, it will be 4. For activity D, it will be 2, and for activity E, it will be 3. For activity F, it will be 5. For activity G, it will be 3. H 5, I 5, and J 3. That is how we will be calculating expected or mean duration for every activity that have, with the help of the data given for their optimistic, most likely, and pessimistic time duration estimates. Now we have variance. So now for variance, the formula is square of standard deviation. So that is actually pessimistic time minus optimistic time divided by 6 whole square. For activity A, pessimistic time is 7, optimistic time is 5. 7 minus 5 is 2 divided by 6 whole square would be 0.11. I have rounded the results, and you would have to round the result to the second decimal place. So we gonna take the same for every activity, as in pessimistic time minus optimistic time and divided by 6. For activity B, it is 0.44. For activity C, it is 1. For activity D, it is 0.11. E, it would be 0.178, 1.78, and then for every other activity I have calculated to the second decimal place. So for variance, we need same durations for optimistic and pessimistic, and then we subtract pessimistic minus optimistic duration, divide that by 6 for the square root, as in we need the square of standard deviation for every activity. That is how we calculate it. After variance, finding variance and mean time, we have third question that says that find the critical path and expected project completion time. For having critical path over this project diagram that we have created already, we first require all the expected time duration which we calculated in question number 2 to be placed on this chart. So I have taken it from the previous question where we calculated the expected time TE for every activity, and we need to place it over this chart on arrows so that we have a fair idea that which activity goes by for how many weeks. So let's put that for activity A we have expected time of 6 weeks. For activity B we have expected time of 3 weeks. Expected time for activity C is 4. For D it is 2. For E it is 3. You can check it here where I have taken all these values from the previous solved question. And then for F it is 5 weeks. For G it is 3 weeks. For H it is 5 weeks expected mean duration time in weeks. And then for I it is 5. For J it is 3. So that is how it will be completed. The first thing, to find the critical path, you have to place the expected duration of every activity calculated on this network chart. Afterwards, we need to find expected completion time. In order to find expected completion time, first we have to complete the critical path. In order to find critical path, it has two phases that needs to be completed. First is forward pass. In forward pass, we go from the first node to the 8th node, node by node, and then in backward pass we go from ending node, which is 8th, to first node, which is 1. Let's see how. Okay, in forward pass we need to find earliest start time, and for backward pass we need to find latest finish time for every single node. So remember that for every single node that we have here, 1 2 3 4 5 6 7 and 8, we need to find the earliest start time and latest finish time. So we will be using two squares with every node, where the lower square will be showing earliest start time and upper square will be showing latest finish time for every node. So we have placed these two boxes alongside every node, and now we need to calculate earliest start time and latest finish time for every node. So to find the earliest start time, we have to have a formula. That formula, first of all, remember that this I denotes the starting node and J denotes the ending node. So earliest start time for every node should be the maximum of earliest start time plus duration of the ending node, duration from start to end node. So what does it mean? Sometimes when you are starting there is just one node, but sometimes when you are starting then it means that you have got two nodes. Like at node 6, this node 6, the activity H is starting after the completion of E and F. So then if it is starting after the completion of two activities, we will be taking the maximum one, the higher one. So let's see how. So for activity 1, earliest start time will always be 0. So before 0 it cannot start, so it is always 0, so we don't have to be worried about it. So for the first node, earliest start time will always be 0. So for the first activity A, how do we calculate the earliest start time? That would be the earliest start time of ith node plus the duration of the activity. So earliest start time for the starting node, yeah, ith node is 0, and the duration for the activity is 6. So for the earliest start time of activity D at node 2 would be 6 plus 0, that is 6. And then for activity B, here at node 3 the earliest start time will be 3 plus 0. For activity C, the earliest start time would be 4 plus 0. For activity D, the earliest start time will be, now here at node 2, which is the starting node for activity D, the earliest start time is 6, so 6 plus the duration of the D activity 2, that would be 8. Then for E it would be 3 plus 3, 6, and 5 plus 4, 9. So in that case, since it is starting at the end of two activities, there are two predecessors E and F, we will have to take the maximum of it. Which one is maximum will be taken. So at activity 6, if we take so for node 6, if we take activity E, then the duration is 3 and the earliest start time for the node 3 for activity is 3. So 3 plus 3 is 6. But if we take F, so the earliest start time for activity F will be 4 and the duration is 5. So 5 plus 4 is 9. So we will take 9 because we have to take the maximum of these two values. So maximum is 9, so we will take 9. Afterwards, over here this case is same. For if we are taking H, then it is 9 plus 5, 14, and if we are taking G, then 4 plus 3, 8. So maximum is the earliest start time for H, 9, plus the duration of H, 5, 14. So we will be putting 14 at node 7 as the earliest start time of J. And then over here for completion, first we have 5 plus 8, 13, and then we have 14 plus 3, 17. So we will be taking 17 as the earliest start time. Now we have to go back in backward pass and to find the latest finish time for every. So for the latest finish time, we have another formula which actually tells about the backward pass. But before we go with that formula, you need to understand, as for the earliest start time we started from 0, the latest finish time will always be the time as earliest start time for the last node. So this backward pass will require you to go from the 8th node to the first node in order, and the formula is latest finish time for the ith node is equal to the minimum of 2. So like this 4 has having 6 and 7 node before it, so we will be taking the minimum of the two values. So it says that the latest finish time is equal to minimum of latest finish time of jth node minus the duration. So let's start from the 8th node. From 8 to 7, the latest finish time is equal to minimum of latest finish time at jth node, which is 17 here, which we already put as it is the latest finish time, and minus the duration of the task between the node 8 and 7. So 17 minus 3, that is 14. Now for node 7, we have the latest finish time 14. After 7 we will go to 6, and then that would be 14 minus 5, that is 9, and then after 6 we have 5. So the ending node for 5 is 8, and the duration over there with the activity I between node 5 and 8 is 5. So 17 minus 5, 12 is the latest finish time at node 5. After 5 we have got 4. Now 4 has got two options. First option is 4 to 7, the other option is 4 to 6. As we had to take the maximum for the forward pass, backward pass we have to take the minimum of the two. So over here it is 14 minus 3, 11, and over here it is 9 minus 5, 4. So which one is less between 4 and 6? That is 4. After 4 we have got 3, so 9 minus 3 is 6, and afterwards we have got 2, so 8 minus 2 12 minus 2 is 10, and then we have got the first node left, which is actually having three options. The first option is 10 minus 6, 4. The second one is 6 minus 3, 3, and the third one is 4 minus 4. So out of these three options, the minimum, we have to take the minimum. So minimum is 4 minus 4, 0. So that is the latest finish time for the node 0. That is how we find the earliest finish time at every node and latest finish time for every node. When we go to find earliest start time for every node, it is said to be forward pass, and when we find the latest finish time for every node, we go backward. It is called backward pass. Pass means going from one node to another, forward or backward. So now for the critical path, you need to understand that all the paths which are going from one first node to the second last node, uh, whatever the route that you take, or this route, see, it could be 1 2 5 8, it could be 1 3 6 7 8, it could be 1 4 6 7 8, it could be 1 4 7 8. You might take the one that is the longest route. So there is one shortcut to it, and that shortcut says that write down all the possible routes from the first node to the last node, as in 1 2 5 8, second one is 1 3 6 7 8, third one is 1 4 6 7 8, fourth one is 1 4 7 8, and calculate their durations. The one with the highest duration will be the critical path. The other one is through formula. You have to have three conditions, formulatic conditions satisfied for that. Then you find the critical path. Those three conditions are: number one, earliest starting time of the starting node is equal to latest finish time of the starting node, means both of the boxes value at one node should be the same. Earliest start time is equal to latest finish time of the starting node. Second condition says that on the path for every node, earliest start time is equal to latest finish time of the end node. Alright, so at this, if there are two nodes, both should have their earliest start time and latest finish time same at the start, and earliest start time is equal to latest finish time at the end, both nodes. I stands for starting node and J stands for ending node. Similarly, there is a third condition that says that latest finish time at the earliest start time at the ending node minus latest finish time uh, at the starting node is equal to the duration. So let's see. So over here we have got this node 1. We will starting from node 1. Both of the earliest start time and latest finish time, they are the same. This satisfies. And then these are not same, these are not same, these are same. So we would have this path definitely be on critical path. And then from here we can see that if we go from 1 to 4 and afterwards if we go to 6, that is fine because they both are same, and over here it is fine as well. So either we take 146 or 147. The thing is that if you go from 4 to 6, the duration is 5, and then 6 to 7, it is 5 plus 5, 10 weeks. If you go directly at 7, then it will be only 3 weeks. So as the critical path says that it is the longest path in the network, we will be taking 1467. We will not be taking 147 since the conditions are meeting here, but still we will be taken 1467 because it is longer route than 147. And then afterwards we have this where the earliest start time is equal to latest finish time. So now I am basically making these arrow red, and red arrow shows critical path, means the path with the longest duration. Now for every node on this path, let's check all these three conditions. Earliest start time is equal to latest finish time, bilkul correct. Earliest start time is equal to latest finish time at the end nodes. Alright, this one is good, this one is good, this one is good, this one is good, this one is good. The third one is earliest start time at the end node minus the earliest start time, earliest finish time of the end node should be equal to the duration. So 4 minus 0 is 4, that is correct. 9 minus 4 is 5, correct. 14 minus 9, 5 is correct. 17 minus 14, 3 is correct. So this is our critical path, 1 4 6 7 and 8, 1 4 6 7 and 8. So how do we calculate expected completion time? By having all the durations over the critical path added up. So 4 plus 5 plus 5 plus 3, that makes it 17 weeks. So this 17 weeks is the expected completion time. Remember I told you a shortcut to find all the routes from the first node to the last, adding up all the durations of the activities on that route and finding the one that is having the longest duration as the critical path. This might give you the same result, but it is always a good idea to find it through all these conditions and formulated conditions. Now next question is, what is the probability of completing the project on or before 22nd weeks. So in order to find the probability of completing the project on or before 22 weeks, we have to have number one, the critical path that we have already found, the activities on the critical path that we know already, and the duration, mean duration, and the variance for the activities on the critical path and their results and addition results. So duration and mean for all the activities on the critical path C, F, H and J, when it is added it is 17 weeks, and the variance of all these activities which is already found is also added up from the first question that we had. So it is 4.78. Now the formula is probability of X having less than or equal to 22 weeks. Being computer student, I am using less than or equal to this way, otherwise you can use the standard sign of mathematics. So this X denotes 22 weeks. This X value is either less than or equal to 22 weeks. So we need to find the probability of X where it is equal to or less than 22 weeks. Now the formula is probability of X minus M. M is now 17 weeks, which is the addition of the expected mean durations in the weeks of all the tasks on critical path, minus M divided by sigma. Sigma is a standard deviation for the variance, which would be the square root of the addition of all variance 4.78. so this will be X is either less than or equal to this, and this will boil down to the whole result of this calculation to 2.28. Now we have to find the probability of Z less than or equal to 2.2. Let me revise. For having the probability of having this project completing before 22 weeks, we have to have the critical path, all the activities on the critical path, their duration, mean time should be added, which is M here, and the variance found and added their result. So that would be the probability of X less than or equal to 22. So X is what? Is the probability of the project completing before or on 22nd week. So if we solve it, then it would become the X, which is 22, minus M, which is the addition of the duration of means of all activities on critical path, and divided by sigma, which is standard deviation. So that would be the square root of 4.78, 2.19 that becomes, and if we solve it, it would become 2.28. so that would be the probability Z is less than or equal to 2. Now we need to find the probability with the help of normal distribution table. We need to use standard normal distribution table now. In order to use a standard normal distribution table, we will have to actually break this value into two parts, which is the Z value in the left column, but it is not showing 0.08 here, so we will be taking 0.8 in the upper column we will be finding. So we have to distribute this value in two parts. Left side, for left side Z it would be 2.2, and upper side it is 0.08. so we will have this 2.2 here and 0.08 over here. At their cross section is our required value, that is 0.9887. This is the way to find the probability using standard normal distribution table above. Now So the value is 0.9887. Probability of the project completing before or 22 weeks is 0.9887. That is, when you multiply with it with 100, this would become 98.87. So this is actually the way to find the probability of completing the project on or before 22 weeks. Let me revise this question fast. The question says that what is the probability of completing the project on or before 22 weeks? So for that we should have three things: the critical path, all the activities on that critical path, and their duration and variances. Afterwards we will add all the durations in the meantime of the activities on the critical path added together, as well as the variance. We would have that this addition of the durations called m and the variance. Then we have to find the probability if x is less than or equal to 22. So let's take x as 22. So the question will be the probability of x minus m divided by sigma, that is less than or equal to 22 minus 17 divided by the square root of 4.78, which is 2.19, and then that is equal to probability z is less than or equal to 2.28. Now to find z we will be using this standard distribution table, and we found out uh, the value by having it on the cross section of 2.2 and 0.08. So we cannot have this 2.28 on this standard distribution table. So will be we will be having these two values. We have to separate these two values so that we could find the required value. So in the left side z we will be finding 2.2, and on top we will be finding 0.08. At their cross section we have found the value, which is 0.9887, and then that is our probability of project completing before 22 weeks. If we multiply it with 100, that is 98.87. So that was the explanation for the PERT. Now let's solve few of the questions from the past papers, and one or two terms that might have gone missing, but they were on the project, like float or slack. It is a measure of the access time and resources available to complete a task. It is the amount of time that a project task can be delayed without causing a delay in the subsequent task, also called free float, or the whole project. Positive slack would indicate ahead of schedule. Negative slack would indicate behind the schedule, and zero slack would indicate on schedule. So we will also be looking this when we are solving questions. The second one is lead time. Lead time is the time by which a predecessor event must be completed in order to allow sufficient time for the activities that must elapse before a specific PERT event reaches its completion. And then we have lag time. It is the earliest time by which the successor event can follow a specific PERT event. These might be three more things that appear in exam. So let's look into few of the questions after this and revise everything with the help of past paper questions. I hope that this would have made several things clear about this topic. I understand that for computer students it is hard to understand a topic from the project management, which is mainly business and the management thing. You people are mostly doing programming and all, But this is also a necessary thing to understand, that if the project is divided among several people and require so many things to be done, and there are so many activities which are interdependent over each other, like for the top down design, it is a good idea to understand that all those subroutines or modules which are made and divided among number of people, how everything will be completed and how long the whole project will take to get finished. So this was video number 1. In second video I will be solving few past paper questions. So until then, take care.